This video is on rational exponents. A rational exponent is an exponent that is a fraction. Radical expressions can be written with rational exponents and vice versa. So a raised to the power of 1 over n, 1 divided by n, is equal to the nth root of a, basically to the 1 power. So for example, x to the 1/5 power is the same as the 5th root of x. A raised to the power of m divided by n is equal to the nth root of a raised to the m power. So for example, x raised to the 2/3 power is equal to the cube root of x squared. You'll notice that the numerator becomes the exponent of the radicand, and the denominator becomes the index. Since a square root is actually an index of 2, x to the 1/2 power is equal to the square root of x. So 16 to the 1/2 power is equal to the square root of 16, which is equal to 4. And all of the properties that apply to integer exponents also apply to rational exponents, and you should be familiar with these properties already. If you're multiplying two powers that have the same base, you add the exponents. If you're dividing two powers that have the same base, you subtract the exponents. If you're raising a power to a power, you multiply the exponents. A product raised to a power is equal to each of those terms being multiplied raised to that power. Same is true with division. And a base raised to a negative exponent is the same as 1 over that base raised to the positive exponent, and 1 divided by a base raised to a negative exponent is equal to the base raised to a positive exponent. All of those should be familiar to you from Algebra 1. So let's take a look at a couple examples here. I want to write the expression -2 times x to the 4/5 in radical form. Notice that this is equal to -2 times x to the 4/5 power. The only thing that's being raised to the 4/5 power is the x, so the -2 stays the same. -2 is not being raised to the 4/5 power. If it were, I'd have to write it like this. Okay, put it in parentheses, then that's going to be -2 to the 4/5 power times x to the 4/5 power, and that's not what we're doing here, okay? We're doing this right here. So this is going to be -2 times the 5th root of x to the 4th. Remember, the numerator becomes the exponent in the radicand, and the denominator becomes the index. Okay. Let's do it the other way around here. I need to write the square root of a b to the 3rd in exponential form. So that's going to be equal to the square root of a times the square root of b cubed. So the square root of a is equal to a to the 1/2, and b to the 3rd is, the square root of b to the 3rd is going to be b to the 3/2 power. And we would just leave it like that. Notice that the only thing being raised to the 3rd power is the b, not the a. And here are several expressions we need to simplify. Let's go ahead and take a look at these. So number 1 is 625 raised to the 1/4 power. What I want to do here is see if I can write 625 as a smaller expression with a smaller base. So 625 is actually equal to 5 to the 4th power. 25 times 25 is 625, and that is being raised to the 1/4 power. To use our multiplication property here, or power of a power property, so that's going to be equal to x to the 4 times 1/4 is 1. I'm sorry, not x, 5, or 5 to the 1 is equal to just 5. So 625 to the 1/4 power is equal to 5. Number 2, here we have 2 to the 1/2 power times 32 to the 1/2 power. Let's see if we can clean up. I have a large base here, so let's go ahead and rewrite that. So this is going to be 2 to the 1/2 power times 32 is actually 2 to the 5th power. to the 1/2 power, or 2 to the 1/2 times 2 to the 5/2. Now that I have the same base and I'm multiplying them, I can add their exponents, or 2 to the 6/2, or 2 to the 3rd, or that's equal to 8. So 2 to the 1/2 times 32 to the 1/2 is equal to 8. Number 3, square root of 3 times the 4th root of 3. In the previous lesson, we said that we actually can't multiply these because the indexes are not the same, but actually if we turn these into rational exponents, we can. So let's go ahead and rewrite this as 3 to the 1/2 times 3 to the 1/4. And now that my bases are the same, I can actually just add the exponents. That's going to give me 3 to the 3/4, which I could leave like that, but if a problem begins with a radical, I want to make sure it ends with a radical. So that's going to be the same as the 4th root of 3 to the 3rd power, or the 4th root of 27. Number 4 is the square root of x cubed divided by the cube root of x squared. So we could actually rationalize our denominator here, but let's go ahead and turn these into rational exponents. I think it might be a little bit easier. So this is going to turn into x to the 3/2 divided by x to the 2/3. And I do have the same base, so if I'm dividing two powers that have the same base, I want to subtract their exponents, so that's x to the 3/2 minus 2/3, which is going to give me x to the 5/6. And turning that back, since it started as a radical expression, let's write it as a radical expression, the 6th root of x to the 5th. Number 5 is 32 raised to the power of -3/5. Since 32 is kind of a large base, I'm going to rewrite that with a smaller base. I'm going to write that as 2 to the 5th raised to the power of -3/5. And since that's a power of a power, I can go ahead and multiply my exponents. So that's going to give me 2 to the -3, which is the same as 1 over 2 to the positive 3, or 1/8. And our last example is the quantity 8 times x to the 15th, all raised to the -1/3 power. So that's going to be the same as 8 to the -1/3 power times x to the 15th to the -1/3 power. I'm going to write 8 with a smaller base. I'm going to write 8 as 2 to the 3rd. Oops. And that's to the -1/3 power times, since I'm raising a power to a power, I can multiply. That's going to give me x to the -5th. And 2 to the 3rd to the -1/3 is going to give me 2 to the -1 times x to the -5th. So 2 to the -1 is 1 over 2 to the 1. X to the -5 is 1 over x to the 5th, or this simplifies to 1 over 2 times x to the 5th power. So in this video, we took a look at rational exponents and how to turn something from exponential form into radical form, from radical form into exponential form, and then how to simplify a whole lot of different sorts of expressions using rational exponents.